All right, my friends, well, welcome to day 11. In this day, we are going to be taking a look at this Raspberry Pi project. It's the Physical Computing with Python project on the Raspberry Pi website. And so we are going to be breaking this project down into a series of steps along our week 3 here with learning Python and physical computing. So just a couple things that you're going to need. There's lots of new components that come with this project, but to start, we already have most of them, so you'll be in good shape. But just kind of double check to make sure you have what you need. We'll talk about these as we get into them more, but the visual layout will help you make sure you have everything that you need. But if you don't have all those right now, it's okay, but just know you're going to need these as we progress through the week. What you're going to be learning this week in the physical computing with Python is know how to wire a variety of components to the Raspberry Pi, this physical component piece. We've already done some of this last week with our LEDs and our buzzer, but now we're going to add a few more components to our equation, to our arsenal, to our toolkit. And you're also then going to understand how to create programs with our physical computing components to create interaction, which is really exciting. In this particular project, if you need a refresher on the GPIO pins, the general purpose input-output pins, this is a great little refresher, some just important things to remind yourself about. It's all right here. We're not going to go into that in this project because we've covered GPIO in the previous weeks, but if you need that, make sure you check that. There's some good little ideas and tips as we get rocking and rolling with the GPIO pins. But I feel like we've already been doing some of this, so you should feel fairly comfortable with these pins that you have on your Raspberry Pi. So we're going to get started here with this project. So what I want you to do here before we get going and you scroll down to the next part is make sure you have what you need. Obviously, you're going to need your Raspberry Pi. This particular project does not use a breadboard, but if you would like to use your same breadboard you've been using, that's what I have here. I've just removed the extra two lights and the buzzer from my equation or from my breadboard. So I just have my regular LED light, my resistor already plugged in, and I have one of my wires. I'm going to need, in this case, this is a male wire on one end and a female on the other, and you're actually going to need two of those because we need to plug our power source to the Raspberry Pi. So all you're going to need, Raspberry Pi, a breadboard if you wish. You don't have to. You can try to wire it just like you see there. Two male to female wires, and a resistor that needs to be at least 50 ohms or higher so we don't burn out the LED. Once you have that, then you can go ahead and progress down, and let's just go ahead and explore what this looks like in the next step. I'm really excited for today, and you will also notice that this step feels very similar to day 6 when we were exploring LEDs with the Scratch. So hopefully you're starting to see some parallels and some similarities as we look at block-based coding to text-based coding and how some of these eventually you're going to see that text-based coding can be way more effective, and block-based coding can be very effective depending on the goal and objective that you have. All right, my friends, welcome to day 11. Can't wait to get started. Peace.